So now let's discuss. Okay, so what we will cover in this lecture: functions refresher, definitions, parameter, return values and variable scope, recursion basics, what recursion is, base cases and call stack visualization, examples and use cases, factorial, Fibonacci, tree traversal and limitations like stack depth. Okay, so Functions definition: a named block that performs a task. Parameters are placeholders in the definition, and arguments are the actual value you pass. Return values let a function gives vague results to the caller. Functions let you organize code into reusable pieces and connect to recursion by treating calls uniformly. Okay, so here is the example. You guys can have a look. Okay, so scope. Scope means the area where a variable is accessible or available in program. In Python, variables can have different scopes. Mainly we discuss number 1, local variables, number 2, global variables. Understanding scope is important because it tells us where we can use a variable. Okay, so a local variable, just wait. Okay, so a local variable is a variable created inside a function. It can only be accessed inside that particular function. Okay, let's understand with an example. Suppose we create a function here, you guys can see. Okay, so define demo parenthesis. So inside the function we create x is equal to 5. This x is called a local variable. Okay, it exists only while the function is running. Outside the function we cannot directly access this variable. Why? Because its scope is limited to that function. Okay, so a global variable. A global variable is a variable created outside any function. So, for example, here you can see x is equal to 10. This variable exists throughout the program. Functions can access global variables. Let's understand with an example. We have x is equal to 10, def demo x is equal to 5. Inside the function, we create another variable with the same name. Now there are two different variables. Global x is equal to 10 and local x is equal to 5. When we print x inside the function, Python uses the local variable. When we print x outside the function, Python uses the global variable. Okay, so understanding scope example. Let's see the execution flow. First, x is equal to 10. Python creates a global variable. Then we define the function demo. Okay, inside demo, x is equal to 5. This creates a local variable. When demo executes, print inside demo, comma x. Okay, so here the output will be 5. Okay, because Python finds the local variable first. After the function finishes, the local variable is removed. Okay, okay, just wait. The global variable remains unchanged. So print global.x here. will show 10. Okay. So important point about global variables. Normally we should avoid changing global variables inside functions. Why? Because global variables can make programs difficult to understand. If many functions modify the same global variable, finding errors become difficult. It is better to pass values as parameters and return results. This keeps function independent and easier to test. Okay, so now have a look on this and read all these things, whatever is written in this PPT. Okay, so functions can accept multiple parameters. This means a function can receive more than one value. For example, here you can see definition student name comma age. Here the function accepts two parameters. When we call student Aisha, okay, the values are assigned. Name is equal to Aisha, age is equal to 20. Multiple parameters make function more flexible. Instead of creating separate functions for different situations, we can create one function that accepts different values. Okay, so when there are many parameters, keyword arguments improve readability. Just wait. Okay. So example student is age is equal to 20, name is equal to, just wait. Okay. So here in the student age is equal to 20, name is equal to Aisha. Here we clearly specify which value belongs to which parameter. The order does not matter. This makes large programs easier to maintain. Okay, so here default keyword and arguments. Default values let parameters be optional. Keyword arguments improve readability and order independence. Here's an example. You guys can have a look. Okay, so now introduction to recursion. Now we come to one of the most interesting concepts in programming, recursion. Recursion means a function calling itself. A recursive function solves a problem by breaking it into smaller versions of the same problem. Instead of solving everything at once, we divide the program into smaller steps. Okay, so when a function calls itself to solve a programming by breaking it into smaller real life analogy, mirrors reflecting mirrors, each call is a smaller reflection until a base case stops the rain. So think about the two mirrors. facing each other. You see a reflection inside a reflection, then another reflection, and so on. Each reflection is similar to the previous one but smaller. Recursions work in a similar way. A function calls itself with a smaller input until it reaches a stopping condition. Okay, so some important parts of recursion. Every recursion function must have two important parts. Number one, base condition. Number two, call. Okay, so base condition, just wait. Okay, so base condition, okay. Base condition is the condition where recursion stops. Without a base condition, the function will continue calling itself forever. This creates infinite recursion. The base condition tells Python, stop here and return the result. Okay, okay, recursive call. The recursive call is when the function calls itself, but each call should move towards the base condition. The input should become smaller with every call. Okay, so let's move to the next PPT. Okay, how recursion works. Let's understand recursion using factorial. Factorial means multiplying a number with all the positive number below it. For example, 5. Okay. It means 5 into 4 into 3 into 2 into 1. The answer is 120. Mathematically, 5, just here you can see 5, just wait. Okay. So 5 into 4 and 4 is equal to 4 into 3. 3 is equal to 3 into 2. 2 is equal to 2 into 1. 1 is equal to 1 into 1. The problem becomes smaller at every step. This is why factorial is a common example of recursion. Just wait, okay? Okay, so factorial using recursion. The function structure is the define factorial n. First we check if n is equal to 1. This is our base condition. When n becomes 1, we stop recursion and return 1. Okay. Otherwise return n into factorial n minus 1. This is the recursive call. Okay. The function calls itself with a smaller value. Execution flow of factorial 5. Okay, here you can see we have done before too. Let's trace it. We call factorial, where is the cursor? Okay, 5. Python checks, is n equal to 1? No. So it returns 5 into factorial 4. Now factorial 4 returns 4 into factorial 3. Then factorial 3 returns 3 into factorial 2. Then factorial 2 returns 2 into factorial 1. Now factorial 1 reaches the base condition. It returns 1. Now recursion starts returning back. This process is called unwinding of recursion. Okay. So guys, have a look on this problem. Okay, so another famous example of recursion is the Fibonacci sequence. The Fibonacci sequence is 0, 1, 1, 2, 3, 5, 8. Each number is the sum of the previous two numbers. The recursive formula is where is the like Fibonacci parenthesis n, Fibonacci n minus 1 plus Fibonacci n minus 2. The base conditions are if n is 0, return 0, if n is 1, return 1. So understanding Fibonacci recursion. Suppose, just wait. Okay, so suppose we calculate Fibonacci 5. Python break it into Fibonacci 4 plus Fibonacci 3. Then Fibonacci 4 becomes Python 3 plus Fibonacci 2. The function keeps breaking the problem into smaller problems. Finally, the base condition is reached. Then values are combined to get the final answer. Okay, so problem with Fibonacci recursion. Although Fibonacci recursion is easy to understand, but it has limitations. Okay, it repeats many calculations. For example, Fibonacci 3 may be calculated multiple times. This makes the program slower for larger values. To improve this, programmers use techniques like memoization and iterative solutions. Okay, so applications of recursion. Recursion is useful in many real-world programming problems. Some important applications are tree traversal. Many computer science structures are naturally recursive. A tree contains smaller trees inside it. Because of the structure, recursion is commonly used for tree traversal. Graph traversal. Algorithms like depth-first search use recursion. The program visits one node and then recursively explores connected nodes. Okay, so here the second one application, divide and conquer. Some algorithms divide a big problem into smaller problems like merge sort and quick sort. They use the idea of breaking problems into smaller parts. Okay, so here the third application is problem decomposition. Recursion is useful in combinations, parsing, and mathematical problems. Whenever a problem can be represented as smaller versions of itself, recursion can be considered. Okay, so here are the limitations. Although recursion is powerful, it has some disadvantages. If there are many recursive calls, memory uses increases. So stack overflow. Python has a recursive depth limit. So stack overflow, here you can see risk of stack overflow if recursion depth too large. If recursion continues too deeply, the program can fail because the stack becomes too large. Performance issues. Some recursive solutions perform repeated calculations. Fibonacci is a good example. In such cases, an iterative solution may be better. Okay, so recursion versus normal loop. A loop repeats instructions using structures like for loop, while loop. Recursion repeats by calling itself. Both can solve repeated problems. The choice depends on the problem. If the problem naturally breaks into smaller similar problems, recursion can make this solution easier to understand. Okay, so let's summarize today complete lecture. We started with functions, what functions are, why functions are useful, how to create and call functions, types of functions, parameters and arguments, positional arguments, keyword arguments, default arguments, return statement, type conversion, math module. Then we moved to the advanced concepts, function scope, local and global variables, multiple parameters, recursion, base condition, recursive calls, call stack, factorial example, Fibonacci example, applications and limitation. The main idea to remember is functions help us organize programs. Recursion helps us solve problems by reducing them into smaller versions of themselves. Keep practicing small functions, trace recursive calls manually, and gradually move towards bigger programming problems. Thank you for watching.